In this video, we're going to solve applications involving exponential functions from 4.3. Let's go ahead and get started. I've got my graphing calculator open to the side over here to help me with solving these. If a single pane of glass obliterates 3% of the light passing through it, the percent P of light that passes through n successive panes is given approximately by the function below. P of n equals 100 times 0.97 to the n. What percent of light passes through 10 planes? So I have 100 times 0.97 raised to the x power. And I'm going to set my table settings to ask here. And I'm going to go to my table. And this is going to be 10. And we want to round this to the nearest whole number. So that's going to be 74%. Then I have 20 panes is going to be 54%. And then explain the meaning of the base 0.97 in this problem. Each pane allows only 97% of the light to pass through. Right? The price P in dollars of a specific car that is X years old is modeled by the following function. P of X equals 45,295 times 0.87 raised to the X. Yeah. How much should a 4-year-old car cost? So we're going to put in X equals 4, and we get rounded to the nearest dollar. It's going to be 25,949. Then a 9-year-old car should cost how much? And that should be 12934. And explain what the base of 0.87 means. It is the growth factor. As each year passes, the car is worth 87% of its value the previous year. Go. And now let's look at number 3. The percentage of patients, capital P, who have survived T years after initial diagnosis of a certain disease is modeled with a function 100 times 0.4 raised to the, and I'm going to use X instead of T. And so according to the model, what percent of patients survive 1 year after initial diagnosis? It's going to be 40%. According to the model, what percent of patients survive after 4 years of diagnosis, after initial diagnosis? That's going to be 2.56. And explain the meaning of 0.4 in the context of this problem. So as each year passes, only 40% of the previous year's survivors have survived. And last question for this section. For this topic, the function capital D of h equals 2e to the negative 0.33h can be used to find the number of milligrams D of a certain drug that is in a patient's bloodstream 8 hours after the drug has been administered. How many milligrams will be present after 1 hour and then after 5 hours? So let's say 2 second ln is e to the power of, then that's negative 0.33, and in place of x or h, I'm going to use x. Then I want to let h be 1, and that's going to be 1.44 milligrams. And then when x is 5, that's going to be 0.38 milligrams. And that's it. We'll come back next time and we'll talk some more about 4.3. See you for the next video.